参加者の方々が入りきるまでもう少しお待ちください。So we're still waiting for a couple more people to trickle in, so please wait for another couple of seconds.はい。それではまだ人が入っている途中のようですが、定刻となりましたので始めさせていただきたいと思います。はじめに通訳機能についてのお知らせです。本日の講演は日英同時通訳となっております。日本語で視聴される予定の方で、パソコンから入られている方は、画面下に見えます通訳と書いてある地球儀のようなボタンから日本語を選んでクリックしてください。また、タブレット端末やスマートフォンからログインされている方、アプリの右下か右上に見えます詳細と書いてある3つの点のボタンを押していただき、そこから言語通訳ボタンを選択。その後、日本語を選んでください。First, I want to give a quick housekeeping announcement. Today's webinar will have live simultaneous interpretations. So for those of you who are planning to hear the discussion in English and log in from a PC, please click on the button with a globe-like icon on the bottom of the screen that says Interpretation and choose English. If you are joining us from a tablet or a smartphone, please click on the button with 3 dots that says More, then choose Language Interpretation and click on English. はい。これで同時通訳の設定ができたかと思いますので、ここからは日本語だけで本編に入らせていただきます。本日は世界中より大勢の方にお集まりいただき、誠にありがとうございます。本日の司会とモデレーターを務めさせていただきます、多摩大学ルール形成戦略研究所の井形明です。本日取り上げる細胞農業や培養肉は、世界でも、そして特に日本では、まだまだ認知度が低いと思われます。しかし、本ウェビナーには総勢535名もの方に参加登録をいただいております。このこと自体が本トピックに関する関心の高まりを示していると思います。このセミナーは、多摩大学ルール形成戦略研究所に加えて、3つの団体より共催、講演をいただいております。まずは、国際 NGO であるグッドフードインスティテュートエイジャパシフィック。次に、テンプル大学現代アジア研究所。そして、細胞農業協会です。本セミナー開催に向けて尽力いただいた皆様に、ここで感謝をしたいと思います。それでは、本日の登壇者についてご紹介します。まずは、グッドフードインスティテュートエイジアのバルン・デシュパンデさんです。バルンさんは GFI アジア支部のマネージングディレクターを務めており、培養肉を含む代替タンパク質に関して調査を行っています。本日は、細胞農業や培養肉といった言葉について初めて聞く方も参加されているかと思います。ですので、バルンさんからはまず、食の分野において世界が抱える課題を説明していただき、細胞農業や培養肉がその解決にどう貢献できるのか、そもそもどのような技術を用いてどのように製造するのか、そして世界の細胞農業食品に関する現状がどうなっているのかをお話しいただきます。次に GFI の米国支部で主任科学者として培養肉を研究しているエリオット・シュワルツ博士からお話しいただきます。現在、人類がどのように環境負荷を減らしていくかが喫緊の課題となっております。そんな中でエリオットさんは、この培養肉を製造する際に、そのプロセスの始めから終わりまで、この様々な要素を包括的に考慮した場合に、どれほどの環境負荷が生じるのかということについて研究をしております。この培養肉のライフサイクル評価に関する最新の研究結果についてお話しいただきます。最後に、多摩大学ルール形成戦略研究所客員研究員、また細胞農業研究会の広報委員長も務める吉富めぐみアビガイルさんに登壇いただきます。吉富さんからは、多摩大学ルール形成戦略研究所が取りまとめを行っている細胞農業研究会における活動内容の紹介や、日本における細胞農業に関するベンチャー企業、投資環境、消費者認知などについてご説明いただきます。そして、この分野において日本がどのようなリーダーシップを発揮しているのか、主にルール形成の観点からお話しいただきます。 3名の登壇者に発表していただいた後、視聴者の方との Q&A セッションを設けます。ご質問のある方は、画面の下か上にあるこの2つの吹き出しのようなアイコンで Q&A と書いてあるボタンを押していただき、できるだけ簡潔に質問を記入してください。なお、ここでご注意いただきたいのが、質問をする際には必ずチャットというボタンではなく Q&A というボタンから書くようにしてください。そして最後に、本日のウェビナーは録画をしております。後日公開予定です。質問を Q&A ボックスに記入しただけでは、こちらの内容は録画には残りません。ただし、Q&A セッションで質問を取り上げた分に関しては録画として残りますので、ご注意ください。Alright, so that's it from me. Varun, the floor is yours. Oh, Varun, go ahead.
Excellent. Thank you so much, Akira-san, and thank you everyone for joining us today for this webinar. As Akira-san mentioned, my name is Varun Deshpande, and I'm Managing Director for Asia at the Good Food Institute. I'm going to be speaking a little bit about cultivated meat as an overview, about the process and the need for cultivated meat, as well as the state of the global market. First, let me offer a quick overview of what we do at the Good Food Institute globally. We are a network of nonprofit organizations present across Asia, the United States, Brazil, Europe, Israel, and in Asia, we're present in primarily Singapore currently, as well as India. However, we are establishing a presence in Japan over the next couple of years. We work across business, science, and policy to establish the alternative protein sector, which of course includes cultivated meat. First, I'll speak a little bit about the challenge and why we even need cultivated meat in the first place. One of the major questions of our time is how we're going to feed 10 billion people by the year 2050 through means which do not negatively impact the planet in terms of our biodiversity, our scarce natural resources, as well as our overall planetary health. And unfortunately, the ways in which we currently source protein, which is primarily through an animal protein supply, do not create the conditions to do so. When we think in terms of sustainability, efficiency, as well as food safety, animal protein supply does present several challenges for the future of our planet, as well as our public health. We've all seen some of these reports that have come out from the likes of the UN Food and Agriculture Organization, the Intergovernmental Panel on Climate Change, the Eat-Lancet Commission, and several authorities in these areas. But the idea here is that industrialized animal agriculture, the large-scale feeding and slaughtering of animals for meat, as well as eggs and dairy, is one of the major causes of the world's most pressing environmental problems. As an example, industrialized animal agriculture is responsible for more climate change than all emissions from the entire transportation sector combined. Any of a major group of environmental issues, whether we're talking about ocean dead zones, ocean acidification, greenhouse gas emissions, species loss, biodiversity loss, any of these things that we all care about, industrial animal agriculture is one of the top 2 to 3 most significant contributors to these issues. Additionally, when we think about efficiency, a major reason for all of this happening is that it takes 8 calories of food fed to a chicken to produce 1 calorie out in the form of meat. So we're using huge amounts of land, water, non-renewable resources, etc., in order to produce all the meat that we need. And then finally, when we think about all of these issues, we need to feed the world's population about 30 to 50% more calories by the year 2050 and 50 to 70% more meat by the year 2050. This means that we'll need to produce an additional 150 million metric tons of meat by 2050, which is not a sustainable output that we'll be able to fulfill. And finally, particularly during the pandemic, it's really important for us to remember that there are several public health considerations that we must bear in mind as we think about how to feed 10 billion people. Industrial animal agriculture actually absorbs about 70% of the world's antibiotics, which are fed to farm animals. This sub-therapeutic use of antibiotics is a recipe for disaster. As the former head of the World Health Organization, Dr. Margaret Chan, said, the world is heading towards a post-antibiotic era in which common infections may once again kill. This will be the end of modern medicine as we know it. An additional twin threat is zoonotic diseases emanating from the industrial animal supply. So if you look at the top 7 causes of human-mediated zoonotic disease, increasing human demand for animal protein and unsustainable agricultural intensification have been identified by the UN Environmental Programme, as well as the International Livestock Research Institute, as being the top 2 causes of these human-mediated zoonotic factors. So let's talk a little bit about the solution, because as we've been saying, meat demand is only going up. By the year 2050, we'll have to feed people 50 to 70% more meat. So our solution is not to say, eat chickpeas, not chicken, or eat broccoli, not beef, because that is not proved to be effective. Meat demand will continue to go up because meat is it's an aspirational food. In many parts of the world, it is considered a symbol of prestige. Especially across Asia, meat demand is expected to go up a lot more than even the rest of the world. So our solution is to accelerate alternative proteins, foods which taste the same or better and cost the same or less than their animal-derived counterparts. These alternative proteins fit across 3 main production platforms. Today, of course, we're going to focus on cultivated meat, but it's important to remember that the plant-based and fermentation-derived protein landscape are also expanding very rapidly. And the reason this is important is that over time, we will see alternatives occur along a spectrum. So we might have fully plant-based products like the Beyond Burger, which is made by a company that is public on the New York Stock Exchange, or we might see plant-based burgers with cultivated fat, that is fat that is produced directly from animal cells. And then, of course, we'll see fully cultivated meat. So zooming in on cultivated meat a little bit, cultivated meat is 100% biologically identical to animal meat. It's produced directly from animal cells by farming those cells directly rather than raising or slaughtering animals in an intensely wasteful process. And of course, when we think about the potential benefits of cultivated meat, and Dr. Elliot Swart is going to go deeply into some of these later, we have opportunities across the spectrum of alternative proteins to offer solutions to many of the world's most pressing problems that we've been discussing. So speaking a little bit about the cultivated meat production process, as well as the commercial landscape. Cultivated meat production entails, as I mentioned, farming cells directly instead of farming the animals themselves. So if we were looking to produce chicken, cultivated chicken would involve taking a biopsy of chicken cells and then producing them at large scale in a clean manufacturing facility. Whatever species of animal we were looking to produce, that's the animal cells that we would be looking to scale up. This process borrows from years of investment from the biopharma industry and the cell culture industry. When we take the biopsy of cells from the animal, we need to feed it a broth called cell culture media. This is composed of ingredients that cells consume inside the body of the animal, food grade ingredients like salt, sugars, and amino acids, as well as other ingredients called growth factors, which are often proteins or signaling molecules. As we scale up production of these cells, we need to transfer them into a bioreactor or a cultivator. If we need to produce a nice 3D cut of meat, we might use what's called a scaffold, which creates the 3D spatial structure inside which the cells may grow. And then finally, we need the cells to differentiate into different kinds of cells. So we might need them to differentiate into fat cells or muscle cells. And that's how you get a final cut of meat that has, let's say, the exquisite marbling that you see in a Wagyu beef or a bluefin tuna. Now, Opportunities exist across this entire cultivated meat production value chain or life cycle to really optimize and to create cost reductions and improvements in functionality so that we can get final products that taste the same or better and eventually cost the same or less than the meat that we all know and love. So the idea is to get really high quality meat that is available at all sections of society. And of course, this is not an easy task, but the idea here is that cultivated meat derives from a rich history of investment in the biopharma industry, billions upon billions of dollars that have been invested in that industry that are translational into this space. And that's why we've seen a very accelerated timeline of adoption. So in 2013, Professor Mark Post in the Netherlands was funded by Sergey Brin of Google and the Dutch government to produce the world's first cultivated burger. This was a lamb burger that was cooked and eaten live on TV. And the entire research project cost about 330,000 US dollars. A couple of years later, Memphis Meats, which is now called Upside Foods, the world's first cultivated meat company, was formed. And since then, we've seen very rapid advancement across the entire landscape. So we've seen advancement in all different types of meats, as well as different geographies getting involved in the space. And that's how you see such an accelerated timeline in areas that you might not expect. So for instance, as of 2021, we're seeing huge interest in the space. We've seen about 100 companies worldwide. We've seen multiple pilot scale proofs of concept that have been set up all over the world. And we've seen regulatory filings, particularly in Singapore, where in 2020, the world's first cultivated meat product was approved for sale in the market. As we think through to 2030, we expect that there will, of course, be technological advancements which will further drive down the cost of cultivated meat. But as of now, our research indicates that we would not need a huge amount of technological advancement in order for cultivated meat to be viable in the marketplace, at least at low levels. And the reason for this is we're seeing very, very rapid, accelerated path to market in terms of the cost coming down. As you can see here from this analysis done by McKinsey, we're seeing very rapid downward pressure on the cost basis of cultivated meat that's even faster than what we've seen in other industries like human genome sequencing. As of 2021, there are about 100 companies that have entered the space of cultivated meat. This, as I mentioned, is a very rapid, accelerated timeline relative to what we've seen from 2015 onwards. So in 2015, there were about 5 companies operating in the space, including Integriculture from Japan, which is closely related to the Shojin Meat project. And as I mentioned earlier, we've seen a huge diversity of companies enter the space from across various geographies, including, of course, Asia, as well as Africa, and across various types of meat and technologies. So we've seen them enter the space across poultry, beef, all different kinds of meat. Seafood in particular has been very popular in cultivated meat.
Varun, this is great. Can you speak a little bit slower for the translators? Thanks.
Yeah, thank you. And just to stress, we've seen people enter the space across both B2C, that is direct to consumer meats, as well as B2B startups. So we've seen people enter the space purely focused on building out those different aspects of the value chain that I mentioned earlier. So there are companies that have entered the space that are purely focused, for instance, on scaffolding. We work closely with many of these companies. So we've seen, for instance, MyoWorks in India that's entered the space purely initially focused on scaffolding. We've seen companies enter the space that are purely focused on cell culture media, that is the nutrient broth that the cells consume. And we've seen cell line development companies as well. So companies that are purely focused on isolating cells and optimizing them for different types of meats. And the reason this is all important is we've seen in various other industries that as you build out different aspects of the value chain, you're able to get with increased competition, with increased technology development, you're able to get more maturity in the space, which drops prices and increases the functionality of the meats. One important development to consider as well is that there have been several strategic investments and partnerships that have been made in cultivated meat from the traditional food, agriculture, as well as corporate landscape. So just to highlight a couple of these, companies like Blue Nalu, which is a bluefin tuna cultivated company from San Diego, Mosa Meat, which was started by Dr. Mark Post, whom I mentioned earlier, Aleph Farms from Israel, Upside Foods, which I mentioned earlier, Future Meat, Super Meat, and Integriculture have all made major strategic partnerships or accepted investment from some of the world's largest food, agri, and general corporate conglomerates. Mitsubishi from Japan in particular has been very active in the space. They've created strategic partnerships and investments with companies like Blue Nalu, Mosa Meat, and Aleph Farms. And these strategic partnerships look like agreements to produce the meats at scale when these companies come to market. And the reason that, once again, this is important is because these large corporate players do have access to large facilities for manufacturing, and they have access to distribution networks that perhaps startups would find difficult to build up themselves. This is an additional key piece of maturity in the cultivated meat landscape. And of course, there's been significant movement in the investment landscape for all alternative proteins as well. For comparison, cultivated meat in particular over the last year has seen a huge uptick in funding. We've seen about 184% growth, so a nearly double amount of funding a year till date in 2021 than was the case in all of 2020. And 2020, the investment that was made in 2020 was larger than almost the entirety of investment that was ever made in cultivated meat up until that point. So we're seeing huge upward momentum in investment in cultivated meat, and we expect this to continue as many of the companies that I mentioned earlier are actually entering the stage where they're setting up pilot facilities. As an example of some of these investment rounds, Aleph Farms, which produces bovine meat from Israel, accepted or closed $105 million Series B round in 2021. And Good Meat, which is the cultivated meat division of San Francisco-based Eat Just Inc., has raised about $287 million purely for their Good Meat division. This follows major rounds of investment that already took place in 2020 across the landscape, including $7.5 million that was invested in Japan's Integriculture. However, when we think about the most active investors in the space, we see that there's major room for growth with respect to investment growing, particularly in Japan, as well as in broader Asia. So we'll see, for example, on this list that there are very few investors based in Asia who have been investing in the cultivated meat landscape in terms of being prolific and their total deal count. You'll see their Real Tech Fund from Tokyo is one of the only investors from Asia that is invested in the space prolifically. And then finally, as I mentioned, in a contrast with the rest of the alternative protein landscape, what we are seeing in cultivated meat is a huge amount of interest, particularly in cultivated seafood. This is driven by a few successful companies like Blue Nalu out of San Diego or Finless Foods out of San Francisco, who are seeing major interest from investors, as well as coming to the stage where they are setting up their own pilot facilities. A major milestone on cultivated meat's path to market is, of course, being able to actually sell in the marketplace. So the pathway for regulatory approval is something that investors, entrepreneurs, as well as governments and consumers have been monitoring very closely and with great interest. As I mentioned earlier, the Singapore Food Agency, or SFA, was the first to approve a cultivated meat product in 2020. So if you're in Singapore, you can actually order the Good Meat chicken bites as well as other products in that market, which is something that is not what we might have expected even just a couple of years ago. In Japan, of course, as we all know, because we're all here today, JACA has been doing fantastic work in establishing a regulatory path to market, and that is still an active dialogue. What's very interesting is that once the original domino of Singapore has fallen, a lot of other countries, including the US as well as Israel, are monitoring the space closely. And there are active conversations across several countries and regions, including the EU, to think through what it might look like to give cultivated meat a path to market. But looking ahead, I think we just want to think about how there might be opportunities to improve in terms of cost basis as well as functionality. As I mentioned earlier, cell culture medium actually accounts as a consumable for the vast majority of the cost of cultivated meat production, about 99% of the cost. So there's opportunities for more people to enter this space. We've conducted several surveys and seen that, especially from the large biopharma landscape, there's an opportunity to further reduce the cost of cultivated meat production through cell culture medium, and we can discuss this more during Q&A. But we have seen some momentum in this area as well. And then, of course, in terms of scaling up the industry, while several companies have entered pilot scale, nobody at this stage knows what a large-scale manufacturing facility for cultivated meat will look like. So we need to really think about how we're going to bring capital as well as technology to bear on the question of scaling up cultivated meat production. There is a need for huge amounts of infrastructure installation in order to make this sector a reality on a large scale. And there's an opportunity here for countries like Japan, as you have done in many other areas, to enter the industry and to help scale it up and to drive down the costs. I'd particularly like to highlight that when we're talking about infrastructure investing and creating large-scale facilities, a significant portion of this will have to come from capital that is quite patient. We've done very detailed techno-economic analyses on this question. And in the most optimistic scenario, with large-scale facilities that produce about 0.3% of global meat demand, we would need to invest about $25 billion at roughly 250 million per plant. So simply scaling up to that size involves a very concerted effort by governments as well as large-scale funders in order to bring cultivated meat to scale and to enable us to produce at costs that can be competitive with conventional meat. Several other organizations like McKinsey have projected out that cultivated meat could have a significant market in that time frame. McKinsey, in its most optimistic growth scenario, estimates that it could be a $25 billion market and produce up to 2.5 million metric tons of meat by the year 2050. By the year 2030. And it's important to remember, as I mentioned, that we need to come together across business, science, and policy to make this a reality. The challenges that we face are considerable in terms of sustainability, security, as well as public health. And yeah, the challenges that we face across sustainability, public health, and security are considerable. And it's important to note that countries like Japan have not yet entered the fray in a major way. If we're going to make this a reality, if we're going to feed 10 billion people by 2050, cultivated meat forms a significant and essential portion of that mix of being able to provide meat that is high quality, that is safe at large scale. And so what I would encourage everyone in the audience today to think about is whether we can come together in Japan and across Asia to help scale up this industry and make it a reality at large scale. Thank you very much. I'll pause here now, or I'll end here now, and I look forward to answering further questions during the Q&A.
Perfect. Thank you so much, Varun. Right on time. I really think that was a great, concise overview of the versioning industry. Now, over to you, Elliot. But before that, please remember that I can hear the interpreters sweating. So please speak as slowly as you can. Thanks.
Varun, if you could unshare your screen, please. Thank you. Okay, welcome everyone. Thank you for being here. My name is Elliot Swartz, and I'm the lead scientist for cultivated meat for GFI's US-based team. And today I'll be discussing what we know about the environmental impacts of cultivated meat production. I'll briefly give a background before diving into the key results from a recent study that GFI commissioned on a life cycle assessment of cultivated meat production. I'll then touch on some additional LCA studies that have been performed, and then wrap up by touching on some of the future directions and recommendations that follow from these results. Recent data suggests that if you account for emissions across the entire meat production value chain, that this makes up about 18 to 20% of global greenhouse gas emissions, 2 times that of plant-based foods, which makes the entire food system nearly 1/3 or more of cumulative greenhouse gas emissions. As Varun mentioned, meat consumption globally is expected to rise by approximately 70% by the year 2050. And we also know that under these growth scenarios for meat consumption, limiting warming to 1.5 degrees Celsius is impossible. You can see on this chart that industrialized nations, including Japan, consume quite a lot of meat. And in order to meet emissions targets by the year 2050, we need to dramatically reduce meat consumption in these industrialized regions, as well as mitigate increased meat consumption throughout the rest of the globe over the coming years. As Varun mentioned, we think that alternative protein technologies like cultivated meat that can compete on the costs, taste, and convenience of conventional meat pose the best chance for success. Today, I'll be talking about the environmental impacts specifically for cultivated meat. GFI commissioned a study to look at the costs and environmental impacts of cultivated meat, along with the research firm CE Delft, which is based in the Netherlands. These studies essentially modeled a large-scale production facility that hypothetically operated in the year 2030. And these studies were released earlier this year. Importantly, over 15 different companies across the supply chain were involved as data and knowledge providers, including 5 cultivated meat manufacturers. The facility that was modeled in the study is capable of producing 10,000 metric tons of a minced cultivated meat product per year. As to the specifics, the cells were grown in stir tank bioreactors, each with a maximum volume of 10,000 liters. And the cell culture medium components were derived from corn, soy hydrolysate, and fermentation processes. This is a schematic of the production line that is in the production facility. We don't have to go into great detail here, but each of these production lines is capable of producing about 3,000 kilograms of meat per production run. And so we essentially copy and paste this production line throughout the facility in order to meet the volumetric requirements of 10,000 metric tons of meat per year for the facility. For the life cycle analysis study, it quantifies all of the inputs and outputs upstream of a product leaving the facility. Essentially, what we're looking at are the environmental impacts to produce 1 kilogram of cultivated meat compared to various forms of conventional meat production. The study also analyzes 2 different energy mixes. It assumes under the conventional energy mix scenario that we would be using a global average that's made up still predominantly of fossil fuels, as well as compares to a best case scenario where the energy at the facility is sustainably sourced. In this case, split equally between wind and solar sources. To quantify the environmental impacts, the authors used what's called the recipe, endpoint, and midpoint methodology, which essentially summarizes various impact categories such as carbon footprint, land, and water use into a single score. So that single score is what you'll see on the y-axis on some of the graphs that I'll show you in the following slides. It's also important to note for conventional meat production was modeled after an intensive West European system that is significantly below global emissions averages for meat production. However, we also assumed that there would be improvements made to conventional meat production by the year 2030. So for all of the data that you'll see, conventional meat production is also assumed to be produced using sustainable energy at farm and feed facilities, to have fewer ammonia and methane emissions, as well as no land use change associated with soy used in the feed. These assumptions collectively reduce the carbon footprint of conventional meat production by between 50 and 53%. So for the comparisons to conventional meat production, we're really talking about an optimized scenario. This graph is a summary slide of the findings from the study that show that cultivated meat can have a lower carbon footprint as well as fewer overall climate impacts than any form of conventional meat if it is produced with sustainable energy sources. You can see in this graph that cultivated meat produced using conventional energy scores significantly lower in environmental impacts than conventional beef production, but slightly higher than the ambitious scenarios in the study that were set forth for conventional chicken and pork production. The gray bars represent the global average carbon footprints of conventional meat production, which have a wide range depending on where you are in the world. You can see that cultivated meat produced using conventional energy mixes scores about the same as the global average of conventional chicken production. However, if that facility was run using sustainable energy, that carbon footprint can be decreased by 80%. So I'll walk through each of these environmental impact categories in a little more detail, starting with the carbon footprint. If you isolate the carbon footprint of cultivated and conventional meat production, you can see that the overall trend from the previous slide is conserved. Cultivated meat produced using conventional energy mixes scores about the same as the global average of conventional chicken production. But switching to that facility to sustainable energy can significantly reduce its carbon footprint. This is a major advantage of cultivated meat production because most of the carbon emissions are at a single point along the value chain at the facility itself, whereas emissions for conventional meat production, including nitrous oxide and methane emissions, are spread all the way across the entire value chain. This gives cultivated meat manufacturers an advantage in that if they are able to locate their future facilities in regions with accessible and affordable sustainable energy sources, they can dramatically decrease their carbon footprint immediately upon production. At large scale, regions that increasingly substitute their meat sourcing or production with cultivated meat or other alternative proteins could therefore see greater rates of emissions reductions in their agricultural sectors. The cell culture medium, as Varun mentioned, is one of the major inputs into the cultivated meat production process. And if you look at the sustainable energy scenario, you can see that the cell culture medium accounts for about 40% of the environmental impacts. Most of this environmental impact is due to fermentation processes upstream in the supply chain to produce ingredients like growth factors as well as amino acids. Cultivated meat manufacturers and the industry more broadly can therefore lower their carbon footprint for medium sourcing if they source entirely from low footprint sources, such as plants or other organisms, as well as growing them in plants or cell-free systems. Researchers from Japan are already clued in to this advantage and have begun to explore microalgae as a source of nutrients such as amino acids and glucose for use in the cell culture medium. The LCA study also examined the feed conversion ratio, which looks at the amount of feed inputs needed to convert to yield a given meat output. This feed conversion ratio has been optimized for decades in the conventional meat industry. However, with cultivated meat, we're simply growing the cells that we need to eat rather than expending nutrients on the metabolism of animals needed to maintain their entire bodies throughout their lifetime. As a result, cultivated meat is more efficient to produce, up to 16 times as efficient as beef production and about 3.5 times as efficient as chicken production. This essentially means that we need fewer amounts of feed to produce the same given quantity of meat. What this translates into is significantly less land being required for cultivated meat production to grow those feed inputs to use. You can see on this graph that cultivated meat, regardless of the energy source that is used to produce it, has significant benefits in terms of its land use, requiring up to between 63 and 95% less land than conventional meat production systems. If cultivated meat and other alternative proteins are able to substitute for conventional meats in our future diets, then we can use this land in more productive ways to rebuild habitats, sequester carbon through ecosystem restoration, for renewable energy development, or simply to feed more humans. The study also examined water use for production, specifically blue water use, which is water that's found in surface and groundwater reservoirs. You can see that cultivated meat produced in different energy scenarios uses significantly less water than beef production, but perhaps slightly more or about the same equal amounts of water than conventional chicken and pork production. It's noteworthy that this metric is very dependent on scarcity and the region in which you're analyzing in. So these numbers should be used as a general guidance because they may vary depending on where you are in the world. Lastly, the study examined particulate matter formation or air pollution. Cultivated meat can be less polluting than conventional meat production, specifically because it essentially eliminates the formation of ammonia particulates that are formed throughout the production of conventional meat on the farm and on fertilizer to grow feed inputs. Cultivated meat does have higher particulate creation for sulfur dioxides, specifically because it requires higher energy use for production compared to conventional meats. The conclusions for the LCA study suggest that the environmental impacts of cultivated meat are primarily driven by the amount and sourcing of energy used at the facility. Sustainable energy, in particular, is going to be key to unlocking cultivated meat's climate and environmental impact mitigation potential, and mutually reinforces our global efforts toward decarbonization. We also discovered that the sourcing and production of the inputs in the medium, as well as how efficiently we use that medium, really can drive the impacts, the environmental impacts of production. So I'm going to now touch on a few additional studies that have been published previously that look at other metrics as well as other comparisons. Other studies that have been previously published looking at the environmental impacts of cultivated meat that are shown down here at the bottom and summarized in this graph also analyze nutrient pollution or eutrophication potential. Animal agriculture is a leading cause of ocean and waterway eutrophication that creates dead zones throughout oceans and other waterways throughout the globe. Other LCA studies suggest that cultivated meat has a significantly lower eutrophication potential compared to any form of conventional meat production, as well as aquaculture such as farmed fish or farmed shrimp and prawns. Importantly, the LCA findings that I reviewed previously are largely in agreement with other studies. In terms of greenhouse gas emissions and carbon footprint, you can see that there's a pretty high range in the cultivated meat category. And this is largely dependent on how much energy is used at the facility, and as we learned, especially how that energy is sourced. We're pretty confident, based on the data that we have today, that if cultivated meat is produced using sustainable energy at the facility, it can undercut any form of conventional meat production, as well as farmed fish production in the future. Similarly, LCA findings found that cultivated meat could require significantly less land than conventional meat production, as well as a similar amount of land to farmed fish production. Water use is also, in other studies, was found to be similar to conventional and chicken and pork production, but significantly less than conventional beef production or other forms of aquaculture. What follows from these findings are several recommendations for companies as well as policymakers. The first, as I mentioned before, is that the location of the facility will matter. Manufacturers should aim to build and construct their infrastructure facilities in regions where sustainable energy is abundant and affordable. The location can also influence other factors such as distribution, resource scarcity, and other socioeconomic effects. So we definitely encourage refined region-specific analyses to be performed. In this case, conducting an LCA, assuming a production facility is in Japan, would be very useful. In addition, comparing facility locations in urban and rural environments would be informative for understanding the effects of cultivated meat at scale. Additionally, manufacturers can aim to source their ingredients in the medium from low carbon sources such as plants, microalgae, or other systems that are cell-free and low impact. Additionally, manufacturers can put pressure or source their inputs and other raw materials from processing facilities that are run on sustainable energy. Lastly, from a research and development perspective, an improved understanding of cellular metabolism can increase medium use efficiency, and the development of medium recycling technologies may be able to further reduce climate impacts. For policymakers, we think that cultivated meat and other alternative proteins should be prioritized as a climate solution within the agricultural innovation mission for climate. Aim for Climate is a multilateral effort that aims to catalyze investments in innovative agricultural technologies. And therefore, cultivated meat, which has significant potential to mitigate various aspects of the climate crisis, should be prioritized. Japan is a coalition member of Aim for Climate and therefore can elevate this onto the agenda. Additionally, we need to fund research and development, as well as leverage some of the world-class stem cell and biopharmaceutical expertise within Japan. You can see in these graphs below that the global livestock and transportation industries have roughly the same environmental impact. Yet technologies that aim to reduce the carbon emissions from each of these respective sectors are disproportionately funded. Alternative protein funding has thus far received significantly less funding than other comparable technologies such as electric vehicles and charging tech. Cultivated meat in particular is just a fraction of this alternative proteins funding amount. Japan has actually already been a leader in this sector by establishing a program with $20 million to fund research that has already led to interesting research publications and results. And we hope that Japan continues to double down on investing in this sector from an R&D perspective. Lastly, as Varun mentioned, cultivated meat will require a large amount of new greenfield manufacturing infrastructure. So issuance of green bonds for cultivated meat, as well as other incentive mechanisms, will be needed to install infrastructure at high rates, while at the same time providing opportunities for decent work and economic growth in both rural and urban economies. Lastly, as we'll talk about elsewhere in the next talk, developing sensible and harmonized regulatory frameworks will be critical to eventually bringing these products onto the market in Japan, Asia, and throughout the globe. I'd like to acknowledge the CE Delft team who performed the work that I showed before for the LCA study, our partner Gaia, who co-commissioned and helped fund this study, as well as all of the collaborators that participated along the way. So thank you for your attention.
Thank you so much, Elliot. I think you were not only on time, you actually gave us about a minute or two extra, so that is excellent. Now, before we move on to Yoshitomi-san, there was a question from the audience about the recording, and yes, today's webinar will be available at a later date. Okay, so Megumi-san, the floor is yours.吉富さん、まず、ビデオの方を開始していただきたいのと、あとちょっと声が聞こえないので、音声の方も確認お願いします。
みたいで、若干画面が止まっております。少々待って。
ちょっと音声が途切れているようですね。また画面の方が、画面共有が解除されました。
すみません、こちら、画面見えておりますでしょうか。
はい、音も画面も大丈夫になりました。よろしくお願いします。
はい、よろしくお願いいたします。私、吉富めぐみと申します。本業は欧州系投資銀行のアナリストとして、日本企業の海外企業への投資をサポートさせていただいています。その傍ら、細胞農業に関するルール形成を行う業界団体の細胞農業研究会の事務局広報委員長として、業界のルール作りに携わっております。本研究会が所属しております多摩大学ルール形成戦略研究所についてもご紹介させていただきます。弊社は日本で初めてのルール形成、つまりルール作りに関する戦略を政策構想から実現にまで取り組むシンクタンクです。ここでいうところのルールというのは、法律だけではなく、SDGs などの国際イニシアチブや ISO などの企画、業界スタンダードの形成などがあります。グローバルに存在するルールの多くは、主に欧米が主導することにより形成されてきた歴史がありますが、他国が作ったルールをただ守るだけですと、日本企業にとって不利なルールが作られてしまう可能性があります。そこで自国の技術や産業がグローバル市場でよりよく評価されるような基準作りに率先して取り組むことで、日本の産業を守る、ないし日本の企業にとってより良い市場を作っていく、またさらには日本の企業や日本の市場が世界に貢献していく場を作るということをポリシーとして活動をしています。 弊社は CRS 細胞農業研究会、この JACA ですね、をプログラムの一つとして運営をしております。我々は細胞農業分野を非常に可能性のあるものとして見ております。畜産物の需要は2050年に15年比で約 70% ほど増加すると予想されている一方で、既存の畜産の方法をこのまま続けていくと、環境負荷、畜産動物への抗生物質の多用による公衆衛生のリスクや、飼料などの価格の不安定化、食料安全保障上のリスクにつながるという見方が強くあります。我々の動物性タンパク質の消費欲を満たしつつ、そういった社会課題解決に貢献する技術として、細胞農業は注目に値すると考えています。細胞農業では、スライドの写真のようなさまざまな動物性もしくは植物性の食材を生産できるほか、我々の生活に必要不可欠な革製品などの生産にも応用できる可能性があり、中長期的にさまざまな産業の構造を変化させる可能性を秘めております。この中で日本には少なくとも3社の細胞農業の会社があります。1社目はこのスライドにはないんですが、培養フォアグラや成長因子を生産するカルネットシステムの構築を行うインテグリカルチャーという会社です。こちらは日本の食肉大手の日本ハムやビヨンドネクストベンチャーズなどから累計11億円を調達しているほか、エバラ製作所といったポンプの会社やハウス食品といった食品企業などとオープンイノベーションプラットフォームを形成しております。そして2社目、ここに培養チキンとして写真が載っているんですけれども、これを開発を進めているダイバースファームという会社で、こちらはミシュラン一つ星を7年連続で取得した日本食の料亭と連携をしています。両社ともエクスプライズ財団という宇宙開発や環境問題対策といったブレイクスルー技術の開発を競わせる世界大会があるんですけれども、この代替プロテイン部門でセミファイナリストとして勝ち残っております。また、両社ともに来年の上市を目指しているということです。さらに、日本の3社目ですね。3社目が日本の食品大手の日清食品ホールディングスが東京大学と連携して培養牛ステーキの開発をしており、こちらは2025年には上市を目指しているということです。また、消費者においても細胞農業や培養肉に関する関心度が高まってきています。日本において細胞農業技術やその可能性について啓蒙活動を行う細胞農業協会が実施したインターネットサーベイでは、培養肉の認知度は約 40%、細胞農業は約 20% との結果が出ています。細胞農業や培養肉に対する印象について調査をしたところ、約3割は普通よりも高い金額を出してでも培養肉を試してみたいと答えています。消費者による培養肉などへの適切な理解が浸透する、すなわち培養肉の量産化や低価格化が進むまでには何年とかかる可能性がある中で、多少高くてもその社会的な意義の観点で培養肉を食べてみたいと考える層が少なくないということは、日本が細胞農業食品の潜在的な市場になり得ると考えていいのではないでしょうか。もともと食品表示ルールの整備にかかるハードルや、いきなり培養肉が小売りに並ぶことで生じる消費者の混乱を鑑みると、個人的には培養肉の提供はまずは外食産業を通じて、通常よりも高い値段で売られている外食産業を通じてであると考えているため、普通よりも高いお金を出してでも培養肉を試したいと答える消費者の存在は、細胞農業産業の成長に欠かせないと考えています。また消費者が培養肉に期待することとして、味が美味しいことが挙げられています。私としてはミシュランスターを取得するシェフが世界で一番多く、調理技術や食を通じたストーリーテリングに長けた日本と、社会課題解決の側面を持った培養肉には親和性があると考えており、旅行が国際的に解禁になったら、日本が培養肉を美味しく食べるために好まれるスポットとなることを期待しています。一方、このサーベイからもわかるように、消費者にとって最も気になる点は安全性で、 これは培養肉を市場で売れるようにするためのルール作りにおいても重要なポイントです。一口に細胞農業といっても、様々な手法があるため、ルールを整備する側がその技術を理解し、適切に評価するためにもそれなりの時間がかかります。そのため、培養肉の販売承認の事例のある国はまだシンガポールしかありません。しかし、細胞農業の将来性や直近の目覚ましい事業開発の進捗、資金調達状況を鑑みて、先ほどのバルンさんの説明の通り、各国でも細胞農業に関わる政策やルール整備について議論が進んでいます。そして日本では後ほどご紹介する細胞農業研究会での業界ガイドライン作りや政策提言に関する活動のほか、例えば自民党では2021年の6月に私もスピーカーとして登壇させていただいたんですが、細胞農業及び培養肉についての勉強会を開催しております。また今年の秋に自民党は細胞農業、自民党の当時自民党の先生をされている方々は、今年の秋にて細胞農業産業推進に向けた議連の設立を行うと決定しました。また政府レベルでは河野太郎大臣直轄の規制改革チームがフードテックについて検討すると発表したほか、21年の7月1日付で農林水産省の食料産業局を大臣官房新事業食品産業部に改組するなど、さまざまなステークホルダーが細胞農業食品を含む新しい食の常識検討に向けて体制を整えているところと理解しています。さて、日本における我々の活動についてもう少し詳しくご説明をします。細胞農業研究会には70以上の団体が所属しており、日本で唯一最大の事業者を対象としたルール形成の場であるという認識です。メンバーの細胞農業企業としては、国内だけではなく、世界で初めて約3000万円ほどの培養肉バーガーを開発したオランダのモサミートや、先ほどのご紹介もあったように、イスラエルでネタニヤフ元首相が試食したことで知られるアレファームズのほか、米国、オーストラリア、フランス、シンガポールなど、様々な国の企業がございます。また、日清食品ホールディングスや日本ハムといった大手食品会社や食品事業を行う商社、三菱商事、住友商事などですね、や味の素などの調味料の会社も含まれます。さらにパッケージングの会社、畜産農家、科学や医薬の分野の会社、法律事務所、家電や計測機器など産業機器メーカーなど様々な企業が参画しており、細胞農業分野の裾野の広さが垣間見えます。また、この赤い星は細胞農業分野で投資や事業開発を行う企業を指し、また青い星は日本企業と連携する海外の細胞農業企業を指しますが、両社が本研究会に多く参加していることからもわかるように、この研究会は国内外の細胞農業に関する情報のハブとなっています。また、イスラエル大使館も日本のルール形成の進捗に興味を持っていて、両国で協力できる分野がないか見たいということで参加されています。研究会の主要な活動内容としては大きく3つです。まず、業界ガイドラインの作成で、培養肉などの細胞農業食品を上司する上で、業務上必要な業界ルールをみんなで話し合って決定をしています。項目としては、細胞農業食品の通称や安全性の基準、また細胞の知財に関するルール、さらには細胞農業の事業者と、あと畜産農家などの細胞の提供者の間で、お互いの権利が適切に守られるための業界ルールの設定などがあります。通称については、実際に複数の培養肉に関連する企業と連携して、現在消費者調査を行う計画を進めています。そして2つ目が、国として細胞農業を振興する上で必要と考えられる政策の提言です。これには、国として細胞農業を促進する上で必要な研究開発への補助に関する内容や、食用のために人の細胞を培養することを禁止するルール、 また、畜産農家が業界に参入する際に必要な初期投資への補助や相談窓口の設定などの構想があります。そして3つ目はメンバー企業への情報提供で、参画企業間で細胞農業分野への参入意欲や事業開発状況に関するプレゼンを行っていただくほか、外部からシンガポール食品庁などのエキスパートを交えたセッションを提供しています。また、この1から3の上記に加えて、広報活動としては、OECD や農林水産省主催のイベント、メディア対応などを行っております。さて、最後になりますが、日本がなぜ積極的に細胞農業産業の振興やルール整備を行う必要があるのかをまとめます。第1は、世界の食領域における日本のブランド力維持のためです。特に和牛などのブランド肉の細胞が不当に使用されないように、細胞の知財に対して適切なルールを作り、国内外に守ってもらうよう発信していくことが重要と考えます。そして第2に、いち早いルール整備で、細胞農業への本気度を見せることによって、今後成長するとみられる細胞農業企業を国内に誘致し、この分野に関する知見を国内に蓄積するためです。また、第3に、この産業を後押しすることで、日本が抱える食料自給率の問題があると思うんですけれども、この自給率の向上や、国家間の対立や災害などを理由としたサプライチェーン断絶のような安全保障上のリスクを軽減し、食料安全保障の確保を実現することが可能となると考えています。そして第4に、菅総理が表明したカーボンニュートラル目標の達成に貢献することも可能と考えます。以上の観点から細胞農業分野は今後の日本にとって戦略的に重要視するべき要素を多く含む産業であると考えますし、引き続きこの分野で活動していくことが重要と考えます。以上で発表を終わりますが、この閉会はメンバー企業を随時募集しているほか、メディア対応も行っておりますので、ぜひお気軽に弊社にご連絡ください。
はい。吉富さん、どうもありがとうございました。それでは、プレゼンターの皆さん、動画をまたつけていただけますでしょうか。Varun, can you turn your videos on so that we can start the Q&A session? はい。それでは、多くのご質問いただきましたので、少しずつ、やっていきたいと思います。So, Varun, can you hear me? Can you turn your videos on? Are you there? There we go. So I'm going to address 2 or 3 questions to each of the panelists and then ask for your answer. And then I'll go back to the second round of questions. For Varun, 3 questions. There was a question from the audience about the profitability of B2B companies, such as those working on cultural media or growth factors. So if you can address that question, that would be great. And then there's also a question on the next steps for Japan in playing a significant role in the cultivated meat industry and what the average person can do to help. And then on the third question, there's a question about someone who's on a recording diet. And I guess this is a question the potential for cultivated meat to have these kind of, high protein, low calorie, delicious and constant nutrition type of meat, or what we like to call craft meat. So if you can address those 3 questions, that would be great. And then Elliot, I think we had about 50 questions addressed to you. So I'll ask maybe 4 or 5 for you. First, there was a question about the environmental impact of cultivated meat being smaller for beef compared to chicken. So please clarify that point. And then second, there was a question about the energy consumption being mainly used for heat for cultivation. And if that is the case, then will excess heat replace the energy demand? And this person is thinking of recycling of heat waste. And then there's also a question asking, have you considered the amount of currently unrecyclable waste due to sterilization of the culturing process specific to culture meat production? And are there any solutions in discussing this? And then last question for the first round, you talked about using microalgae as raw materials. So does this mean that consuming raw materials such as corn will further reduce the environmental impact, especially the impact on LCCO2? そして、吉富さんにも、3つ質問を投げたいと思います。まずは、この日本がこの培養肉業界でどのような役割を果たせばいいのかと、話していくべきなのかということと、あと、一般的な人がどういうふうにこの培養肉業界を盛り上げていく上で、お手伝いできるのでしょうかという質問。また、この業界を応援したくて寄付をしたい場合、どこに寄付をすればいいですかという質問。これに関してはもちろん、多摩大学ルール形成戦略研究所にぜひということだとも思うんですが、他にも何かあれば、ご意見いただければなというものと、あとは、今日の、お話は培養肉だったわけですけれども、例えば、牛乳といいますか、例えば牛乳だったり、バターだったり、チーズといった、デイリープロダクツ、乳製品の場合はどうなんですかという質問。そして最後が、この培養肉が、一般的なこの食品サービスとして売られ始めたときに、あれですね、このサステナブルエナジーの話ですね。すいません、ちょっとこれ質問が分かりにくいんですけど、多分この、一般的に商品化して物を売るときに、このサステナブルであることということがどのような、消費者にとってのプラスになるんでしょうかというような点についてお答えいただければと思います。So let's start with Varun, then Elliot, then Megumi.
All right, so just clarifying, Akira-san, that first question, which is related to B2B players in the industry, I would like Elliot to come in on that as well, but I'll just answer it briefly up top. So the idea within the industry, as I was mentioning earlier, is that in order to see a thriving, diverse landscape and maturity in the industry, we will need to see more players enter from the B2B angle. So many cultivated meat companies from the beginning have been focusing on creating their entire technology stack in-house. So everything from cell line isolation to cell culture media optimization to scaffolding if they need it, to bioreactor design, etc. However, this is not how a mature industry would operate. So if you want to look at, for instance, the industry of smartphones or computers, whereas initially the first players in those industries would have looked to in-house their entire technology stack, very rapidly there emerged an entire industry of creating components for smartphones or creating components for computers, right? So this is very similar to what is happening in the cultivated meat industry. In those projections of multi-billion dollars or $25 billion by 2030, a significant portion of that will be the B2B landscape rather than just the B2C players. In terms of the profitability of individual players, it's hard to say right now, but once again, many of these companies, most of the companies, I would argue, on the B2C side, will need to source a significant portion of their technology, of these individual technology elements from outside the company. And we're seeing, as I mentioned earlier, strategic partnerships that are leading in that direction. So larger pharmaceutical, food, agri, feed companies that are partnering with the cultivated meat companies to do things like optimize cell culture media for specific species of animals like fish, etc. I'll move on to the next question, Akira-san, if you don't mind, which was related to what can Japan specifically do next? Thank you so much. And again, Megumi-san can speak a little bit further to this, but it's important to note that any new industry like cultivated meat will require an enabling environment across science, business, and policy. Some of the priorities that we had identified during the course of this discussion here today included research as well as scale up and incentives for business. What we are seeing in other countries is the creation of research and knowledge hubs to conduct pivotal research advancing the industry, as well as to train the next generation of students and innovators in this space. As a couple of examples, we have launched coursework in universities in Singapore, Israel, and the US and around the world, which actually teaches the next generation of students and innovators and entrepreneurs the science and business of cultivated meat and other alternative proteins. So this is an area where we think Japan can play a huge role, is in educating the next generation of talent to enter the space. Additionally, we've created, or different countries around the world have created, centers of excellence that are focused on cultivated meat and cellular agriculture. So as an example, in India, in Mumbai, about 3 miles away from me, we have a project that's being set up called a Center of Excellence in Cellular Agriculture that's focused on doing this, which will undertake pivotal research at the lab and the pilot level to advance the entire space. In fact, a couple of days ago, or just yesterday, it was announced that the United States Department of Agriculture has funded at Tufts University and a few other universities in the region a National Institute of Cellular Agriculture, up to $10 million over 5 years. So these are the kinds of things that potentially need to happen at the research and development stage, where creating centers of excellence can advance the state of the science, can bring down the costs, and improve the functionality of a lot of the parameters associated with cultivated meat. And then finally, as both Elliot and I have been saying, scaling up cultivated meat remains a question or an opportunity across the world. Japan has done a huge amount of work in other industries like solar energy, creating the initial momentum, which actually enabled those industries to become viable commercially. And so we think that that is both necessary as well as a huge opportunity in cultivated meat as well, to create, as Megumi-san was saying, both environmental resilience as well as a huge sunrise industry for Japan. So we think that entering the space with research funding, centers of excellence, training courses for the next generation of talent, and incentives for business to help to scale up this industry are areas that Japan could look at immediately.
Thank you, Varun. Now, Elliot.
Yes, thanks. Starting with Haruka Sakurai's question, I believe what you're referring to, the slide that I showed, was essentially the carbon footprint reductions due to the assumptions that the authors took in the study that conventional meat would be more efficiently produced by the year 2030. So the details are in the report that I linked in the chat, but essentially we wanted to put forth a scenario where conventional meat was very optimized so that cultivated meat was not given an unfair comparative advantage. Therefore, there were several assumptions that were taken that would reduce emissions in the conventional meat supply chain. And those were the numbers that I think you're referring to. For the next question, as raw material around microalgae, I think this is an interesting exploration. And I can't speak to the specifics of whether or not that would be significantly reduced compared to, let's say, corn or other crop materials. I think we need additional research that makes different assumptions for feedstock in order to understand the best sources of raw materials from an environmental perspective. I will mention that one of the earliest studies that came out really a decade ago assumed that a lot of the feedstock would come from cyanobacteria cultures in open ponds. And so the land use in that study, because it essentially uses no land, the comparisons are quite dramatic. So this speaks to, just underscores the point that where you source the glucose and amino acids will matter for your environmental footprint, but we need additional studies to be performed in order to really understand the variation that we see in environmental impact between different feedstock sources. The next question, I believe, is around waste, and any solutions with waste and byproducts. There were also some things related to recycling and other questions in the chat. So on waste and byproducts, the major byproducts or co-products potentially produced by cultivated meat would be lactic acid, ammonia, carbon dioxide, as well as exosomes and other macromolecules that are secreted by the cells during production. Now, theoretically, all of these could be used as a co-product into another industry. And we are actually funding a study that is exploring the use of waste stream valorization for cultivated meat, as well as other alternative proteins. We're very interested in understanding how side streams from existing food and agricultural industries can feed into the cultivated meat industry, as well as what co-products could potentially be produced by the cultivated meat industry. In terms of medium recycling, essentially what companies are going to want to do is maximize the efficiency that they get from their cell culture medium. And they're going to be balancing the amount of fresh medium that's needed to come in with the amount of waste medium that needs to come out due to the accumulation of some of those metabolites, like ammonia in particular, that can be toxic to cells as they accumulate in the bioreactor. So recycling systems may aim to remove certain metabolites like ammonia or lactic acid while recycling water and other smaller nutrients back in. On a more practical level, recycling may also refer to the use of something like a dialysis membrane to capture growth factors and other proteins that still have bioactivity and can be captured and then recycled back into the bioreactor. There's some evidence in the literature that this is a tractable approach, and there's some work being funded by Merck, the life science company, on medium recycling technology development. But there's still, it's suffice to say that medium recycling, as we imagine it or envision it, does not really yet exist, and there needs to be further research done in that category. And let's see, I think there's one more question that we wanted to touch on. Kira, can you remind me which one that was?
Have you answered Kimiko Hong's question?
Yeah, so that's what I tried to touch on with that last answer.
Okay, gotcha. I thought you were addressing Suzuki-san. So, okay, this is good. I'll get back to you with the second round of questions.
Okay, yeah, so let's go move forward.
All right, Megumi-san.
質問いただいてたかと思います。まず日本の培養肉業界での役割に関してですが、まず一番この業界に日本として貢献できる内容というのは、やはりルール作りの前例を作ることであると考えています。またそのルール作りをすることによって、国際的にその細胞農技術に対する理解を促進させるとともに、国内にいる3社企業ですとか、国内から海外企業に投資している会社に対してよりポジティブな環境を作っていくことが大事だというふうに考えております。また他にも日本にはさまざまなブランド食品がありまして、でこのブランド食品に対する細胞農業分野における取り扱いに関するルールを整備する。これはこのルールを整備することによって、例えばフランスですとか、その他のそのブランド食品を抱えている企業の失礼しました国の中でのルール作りにも貢献ができるのではないかというふうに考えております。また最後に先ほども申し上げたんですけれども、日本には非常に優秀なこのシェフがたくさん存在しますので、そういった方々にその細胞農業に関する情報をですね、適切に伝えてもらえることができるのではないかなというふうに考えています。 これが1つ目の質問のお答えです。で、2つ目の寄付に関しては、非常にですね、ありがたいお話だというふうに思っております。日本にはその細胞農業研究会の他に、このイベントをホストされている日本細胞農業協会というコミュニティですとか、精進ミートプロジェクトというコミュニティがございますので、これらのその参加これらの団体の活動をそれぞれ調べて、ご自身の価値観に合ったところにご連絡されるのがいいのではないかというふうに考えております。すいません、3つ目のお答えに行く前に、1つ目のご質問の中で、その一般的な方がどう貢献できるかということに関してお答えをすると、この既存の、そうですね、積極的な情報発信と、あと、皆さんの周りにすでに存在している、その環境負荷、なんでしょう、エコフレンドリーな食品に対してより関心を持ってもらう、この2つが重要ではないかなというふうに考えています。情報発信については、この産業を盛り上げていく上で、様々なステークホルダーを巻き込む必要があって、例えば畜産農家さんですとか、あとは新しい技術を使った食品に懐疑的な消費者様もいらっしゃるので、そういった方々も将来的には巻き込みたいと考えております。そういった中で身近な方がこういった細胞農業技術に対して情報発信をしているというのは少なからずプラスになると考えるので、例えば先ほどご紹介した精進ミートプロジェクトですとか、細胞農業研究会ですとか、私のもうそうなんですけれども、ツイッターやフェイスブックなどで発信をしている情報を拡散ご協力いただけると非常にありがたいと思っております。スピード大丈夫ですかね。で、3つ目の牛乳、バター、チーズなどの場合についてなんですけれども、こちらは現在我々が作成をしている業界ガイドライン提言書の中に大枠としては含まれています。そういった培養チーズなどのその分野にも応用できるような枠組みになっています。ただ、一方で、この研究会、我々の研究会に、その培養乳製品の会社というのがいないので、もしかすると、そういった会社さんにも参加していただけることで、より良い提言書ができるのではないかと考えています。そして4つ目、サステナブルであることが、この食品、日本国内によってどういった点でプラスなのかに関してなんですけれども、私は特にその Z 世代やミレニアル世代など、フレキシタリアンの人数が多い層に対しては非常に刺さる分野であると考えております。以上です。
どうもありがとうございます。So we still have dozens of questions, but we only have 2 minutes left. So why don't I ask one more question to each of the presenters, and then we'll end the session. So Varun, I'm going to ask 2 questions. There was a question on texture of cultivated food as well as cost of cultivated food. So if you can give us a 30-second overview of that, that would be great. And then to Elliot, there was a question about how there is a report from Meat Atlas indicating that GHG emission and energy consumption in cultivated meat production could be larger than that of conventional meat. So if you can address this question, that would be great. そして最後、吉富さん、先ほど培養液の素材として、マイクロアルジー、藻類についての質問がありましたが、こちらについて何か日本で研究がないかということについてと、あとこの細胞の採取元についての質問で、例えばこれ培養牛肉であればどのような牛から細胞を採取するかが重要になってくると思いますが、畜産業の方がどのようにこの点を理解しているか教えてくださいという2つについてお答えいただければと思います。So let's go in the same order again, Varun, Elliot, then Megumi.
Yeah, thank you so much. We can link, as Elliot has already linked the life cycle analysis, we can link our similar techno-economic analysis as well that goes into detail about some of the things I talked about related to cost of cultivated meat. And it also is similarly detailed as Elliot has been talking about the life cycle analysis. As I mentioned, in the most optimistic scenario, we could bring down the cost of cultivated meat per this techno-economic analysis to being about $5.66 by 2030, which is competitive with premium meats or beef in some of the more developed countries. But there are a number of assumptions related to that in terms of what we will need to accomplish in terms of the types of funding available, the types of scale up, etc. As far as texture is concerned, it is of course easier to produce a soup of cells than it is at this point a 3D cut of steak with wonderful marbling and diversity across the meat. However, different companies are trying different things. As I mentioned, scaffolding technology to create thick 3D cuts of meat, as well as techniques like 3D printing, extrusion, etc., to make the final cut of meat. So we are optimistic that we'll be able to get these whole cuts, highly textured meats, as you see that come out of the animal meat industry. But there's certainly more work that can be done in that direction.
Thanks, Varun. Elliot?
Right. So I'm not familiar exactly with the Meat Atlas report. There have been previous studies that were published that modeled out the effects of carbon dioxide production due to energy use over extended timeframes, that as carbon dioxide remains longer in the atmosphere than other greenhouse gases, that over the long term, if cultivated meat as an energy intensive process were to be run on sort of fossil fuels, then yes, it could be more impactful from an environmental perspective than conventional meats. But in order to reach or cross over those thresholds, you need to extend those timelines quite significantly, such as in the hundreds of years, in order to have that effect. Of course, we need to be switching and decarbonizing our energy grid much faster than that. A key point here is that the growth of the cultivated meat industry will not occur overnight. It's going to take time for this industry to scale up. And during that time, nations, including Japan, but really all across the world, will be decarbonizing their energy grids, making it more likely that facilities can be run on more and more sustainable energy, in the same way that we rely on electric cars to pull power from the electricity grid, but over time become cleaner. So I think really the data that our study suggests, which by the way uses very conservative assumptions for energy use. So the energy use at this facility is quite high. And in many cases, it may not even be required to be that high due to assumptions that we use for cooling of the bioreactors, which is a technicality that I would suggest diving into the report for those details. But nevertheless, we feel fairly confident that if cultivated meat is produced using sustainable energy at the facility, it would be cleaner than conventional meat production. There's pretty strong data to support that, we think. Thanks.
Thanks, Elliot. Now, Megumi-san.
はい、まず藻類の研究に関しましては、日本では東京女子医科大学の清水達也先生という方が光エネルギーで増えるクロレラなどの藻類を活用して低コストで培養肉を生産する研究を行っております。そして2つ目の質問、細胞の採取元に関してなんですけれども、その現在、その培養肉事業者と連携をしている畜産農家さんの中には、このご好意で細胞を共有されている方もいます。ただ、きちんとした枠組みは将来的にこの細胞農業研究会で 作っていきたいと思っております。で、その枠組みというのはどういうものかというと、やはりその畜産農家さんが明日から自分の、持っている、例えば牛ですとかチキンの細胞を培養肉事業者さんに売りたいとなった場合に、どういった初期投資が必要になってくるのか、あとどういった情報を、どういったことを念頭に置かなければいけないのか。で、これらの、情報ですとか、初期投資のための補助金に適切にアクセスできるような環境を作ることが大事であると考えております。なぜなら、日本の畜産農家さんは、もちろん大手もいらっしゃるんですけれども、多くはその家族経営ですとか、その非常に小規模な畜産、企業の集まりですので、あまりハードルの高いことっていうのを、その一方でですね、細胞農業って非常に新しい技術ですので、全く前提知識がない中で、この技術を導入するっていうことにはハードルが高いというふうに考えておりますので、この業界として、もしくは、ひいては何か自治体と連携などもして、こういった分野に参入ができるように、なるべく早くルールを作っていきたいと考えております。
どうもありがとうございました。まだ回答できなかった質問もあるのですが、時間もすでに少しオーバーしてしまっておりますため、これで本日は終わりにしたいと思います。本日の講演内容及び Q&A で出てきた質問の多くは、チャットにも貼られております報告書の方に書いてありますので、ぜひこちらをご覧いただければと思います。それでは本日は本当に多くの方にご参加いただきありがとうございました。引き続きよろしくお願いいたします。
Thank you.
Thank you.